Well, let's get it started. First of all, welcome back to our CTO office hour. This time around, we're going to have a special guest from the team. He's our director of DevOps, and as we grow our system and try to serve so many tokenized communities, and we are facing interesting challenges when it comes to the backend system, the front end system, and all the infrastructure we use. So luckily, we have Ross on board, and he has been really valuable and instrumental to scaling up our infrastructure in the cloud. And today we kind of invite him to the stage to share some of the insights with the broad audience here. Hopefully, you will get some interesting observations and inspirations from here. That being said, I'm going to hand the floor to Ross.
Sure, thanks for that, Raymond. Hey guys, nice to meet you all. So yeah, I've been here for a couple of months now, I think, maybe 5 or 6 or so. And yeah, kind of as Raymond said, come in to help with the scaling. So I guess let's kick off. So I wanted to start off by talking a little bit like, what is scalability? What does it mean? So, I mean, the raw definition is how a system can handle an increased load, say more users, more features, more things going on. And typically is by adding resources. If you have a system that can handle more requests without adding resources, then that's kind of a golden a golden egg. It's pretty rare. But why is this important? User experience, kind of protecting the user experience and maintaining the user experience as the number of users grows is very, very hard. And so we did it a number of ways by increasing capacity, optimizing the performance, increasing how we use resources. So yeah, I guess pretty much on that. So let's keep going. So where did we start? We started off using an open source tool called Node-RED. So this is a visual tool where you can wire together different services. You can say, I want to talk to the Discord API. I want to talk to, say, a Telegram API. I want to talk to blockchain.info, for example, and wire together some flows there to kind of say, if this event happens, do this. A little bit like Zapier, if you folks are familiar with that, but more focused towards customization and kind of plugging together anything you can imagine. So this is, I guess, the key points of this. It's visual, right? You've got a drag and drop interface where you can connect together different flows, different, they're called nodes. And I guess these nodes are pre-built for a wide variety of tasks like data processing, communication. It's very extensible, right? There's a lot of community modules out there. It's very easy to create kind of custom logic or to utilize what's there already. And the community is really big. So I guess it was very easy for us to use to get started, to plug together all the pieces and get the kind of first iteration of the product. However, there's some issues when scaling Node-RED. So it's single-threaded by nature, which means that it can only process in one thing at a time. So you're limited to how many users and how much you can put through that. And also the state management, right? So what does state mean? For an application, it's something that's in progress or something that's remembered. Because this is pretty limited, it becomes challenging when scaling out. It's very hard to run multiple instances of these and have them coordinate the work so that they're each only doing one part rather than them all doing the same work 3 times, right? Which this is good from an availability perspective because it means if the first one fails, the second one would take over, but you're still not increasing the capacity through the system. And also as the complexity increases, as the logic gets more mature, there's more going on there, the visual editor kind of starts to hit its limits a little bit. It becomes harder to maintain. And I think it's also worth pointing out there's some performance overheads, right? The ease of use there comes at the cost of performance, and it's not so good for high throughput or low latency scenarios. So from there, we kind of migrated to Loopback, which, unless I'm mistaken, was co-founded or created by Raymond, our CTO. So Loopback is a framework for Node.js that makes creating and exposing applications really easy and really extensible. So a lot of the kind of concepts there from Node-RED with regards to the community and the extensibility and the documentation is really there. And these tools make it really easy to extend. So we can define the data models, we can define the relationships between different components of a system, and then automatically generate the interfaces that are then used by, say, the website, the web app, the command center to hit Discord. They can be automatically generated, which is typically pretty challenging. And then also the connectors there. So a lot of these are pre-built for the multitude of databases and services, which means that it's kind of easy to use. A lot of the plumbing is done. You're kind of starting up from, I don't know, it's like if you're building a skyscraper and you start at the 10th floor, to kind of steal a Jobs analogy. But anyway, you can also use a lot of the Node ecosystem. So if there's a library out there, it's quite easy to plug it in. And Node is by far the largest, well, in my opinion. maybe folks disagree. But then I guess the key thing here, again, is the extensibility. So it's very easy to create custom components and plugins to fit your use case. So I mean, that's been very successful. We're still running with Loopback. And I guess where we run today, so we're using a tool called Elastic BeanStalk from AWS. So this is a platform as a service. Its key features, if you like, are simplifying deployment, management and scaling of web applications. You get a lot out of the box with this, kind of, I guess, along the same kind of thought chain as the other tools. So Elastic BeanStalk will automatically set up the server instances, any storage you need. It'll automatically handle updates. It will integrate with other things in the AWS ecosystem. It handles load balancing, or more likely kind of traffic distribution. So what does this mean? This means, coming back to the request distribution issue I mentioned earlier, when you have lots of servers, you need to make sure that they each get their own piece of the load and the request. This means that we can scale to support many systems. I think we're running on about 70 to 80 instances right now, as of the last time I checked. It dynamically changes from time to time. And then with that side as well, you've also got things like health checking are automated, and various other things like auto scaling we kind of talked about a little bit. So based on the utilization, Elastic BeanStalk will try to increase the capacity or decrease the capacity. So this is really important from a cost optimization perspective. So this is balancing cost with user experience. So it's very easy to say, hey, just give me 500 servers. I want them all the time. But it's very expensive to run that, especially if they're idle, right? Like the request typically is not a perfectly even distribution. So you would get a lot of spikes and a lot of kind of troughs in those requests. So yeah, this is really important. And then the monitoring and logging, it's got a lot out of the box integration with AWS kind of CloudWatch. So that gives you things like metrics, it gives you things like alarms and dashboards. And as long as you're solely within the AWS ecosystem, it's pretty good. Elastic BeanStalk works really well when things are kind of, I would say, small to medium. And the problem with this is things like CloudWatch and the other tools, they bill you on a request basis. So once you hit a certain point, it starts to become very expensive. For example, logging, it can very easily become several thousands of dollars when, for example, you have a spike in traffic, which, it's kind of, I guess, a balancing of concerns. So kind of coming onto this, like, what limitations, like what issues do we have with Elastic BeanStalk? So you're very limited. You're kind of stuck in the box. And if what's in the box works for you, it's really good. So you have a very high level of abstraction. It's very simple. It's very easy to work with. But that comes with reduced control. So for example, with containers, with Docker and these kind of tools, you get a much deeper level of customization and control. You can define exactly the versions you want, exactly the configs, and they will go with the app. Whereas coming on to the second point here with dependency management and consistency, so Elastic Beanstalk will typically compile the app on every server. So there may be subtle differences even between servers, depending, like if, say, one spins up tomorrow, one spins up today. That was a weird way around for that, but anyway. It could be that a new version has released, and if your log file isn't done very specifically, you could get kind of dependency drift and things like that, which is very hard to manage and debug. So as things scale and you have more and more servers, it's a lot harder to log into every server and ensure that consistency and see what's going on. So yeah, it's kind of, and especially when you lifecycle the app, so when you're going through a development lifecycle, a pre-production lifecycle, and a production lifecycle, there'll typically be quite a lot of time between that. So the chance for drift increases, which is not good because you want things to be more stable as they get to prod. And but again, that's something that kind of Docker helps to address because the same image is shipped across all environments. And you also typically have greater parity with the, say, the engineer's local environment on the laptop. It's also highly proprietary. So it's only in AWS. There are other solutions, like there's Heroku, kind of Google have one, but you're kind of swapping the problem in one side for the same problem somewhere else. So it doesn't really kind of help. And kind of coming on to the last point, the more it scales, you have a bit of a hockey stick growth in the how long it takes to deploy the application. So recently, when we had the token launch, we had an issue with our API when we had to take the site down. And I think the code change took us something like 5 minutes to make and like over an hour and a half to roll out and verify. So things like that starting to hurt us. And I guess also kind of the orchestration, sorry, kind of done this out of order, but it's very basic, the scaling that you get. It's kind of, it doesn't have a kind of deep and a rich understanding of your application. With container-based approaches, you can say in a much more fine-grained way, for example, if my request load spikes, spin up more instances, and that will happen an order of magnitude quicker than it will with Elastic Beanstalk. So taking the 60 to 90 minutes example, which is a bit of an extreme because we had to run through the full dev to prod lifecycle, whereas typically we would maybe just increase the capacity in the environment. That can be done in minutes instead of, well, an hour and a half. So yeah. And I guess that kind of brings me on to, I wanted to do a bit of a shout out on the marketplace, which is some of our recent innovations. So we launched this tooling to enable the community to lower the entry level for other developers and other communities to come in and add their own tooling and I guess leverage us as a delivery mechanism and a platform. So as of now, just under 50,000 communities. So yeah, if everyone can invite people to add us, that'd be great. We'd love that. We love having more users. 8.2 million verified wallets, which is pretty cool. I think that this is not, please don't quote me on this, but I think it's only MetaMask in the ecosystem that's ahead of us, which is, yeah, I find that really exciting. And kind of a shout out to a couple of the live marketplace apps. So kudos. So this allows you to give and receive kudos to members to show appreciation. Say, for example, someone helped you with a problem or someone is helping a newbie to join. Our POAP mini app, which I know Chibi is fond of and makes use of often. So this allows to simplify the distribution of collectibles for communities. Kind of worth talking about Snapshot. Snapshot is great. Snapshot works to streamline DAO participation. So that's working to improve the accessibility for everyone, and you should definitely check them out. Sobel is building a vision with attention to detail and communication to collaborate together for better user experience and growth. And then Meme Market, I love those guys. I love memes. I'm a bit of a memester, but they allow you to easily create contests and distribute those to folks. Charmverse is lets you. I'm sorry. I'm drawing a blank. Yeah, I will maybe loop
It's
clients around it once.
it's probably a little like a Notion for Web3.
Thank you. Yeah, apologies. I didn't know how to summarize that. So technical documentation and community reach kind of meets Web3 would probably be the tagline I wish I prepared. So apologies to Chandler's. And then Spark AI, the Chat GPT, which I'd be very surprised if you haven't heard about at this stage, is a Discord engagement bot, which is designed to increase community engagement with the aim to reduce the kind of repetitive answering common questions. For example, go to Wagami, take a look at our token if you haven't claimed it. But where can I find that? Things like that, for example, it can be pretty good for. And yeah, that's kind of everything I'd put together. So if you have any questions or any follow-up comments, I'd love to take those, or maybe for Raymond.
Yeah, that's a great high-level overview how we evolve from a single process, Node-RED-based backend into a fairly sophisticated, like a platform as a service-based solution, and we continue to make that improvement into a containerized approach and start to utilize the cloud agnostic or cloud native approach to support the different microservices that get orchestrated together with multiple containers and give us the benefit of that kind of flexibility and control. So the end goal is really to provide a scalable system that we can continuously grow with our adoption and attraction from the tokenized community. So I want to inject some color here as well. Like for each phase, we're facing different challenges, right? So at the beginning, we only serve a few hundred, communities. Then we're happy to do that with a single process. As the number of, communities that use Collab.Land grows, then of course that's not going to scalable. So we kind of solve one problem at a time, and we moved to a API-based infrastructure and start to use AWS as a backend front platforms, and that gives us the horizontal scalability and solve some of the problems such as the state management, and also we try to figure out what's the divide of responsibility, right? So, for example, we have APIs that sort of expect to function as a request response fashion. You send a request, you expect to see some response right away. So we create specialized servers for our backend to support that. Like say we have API server, then we have a bunch of different job servers that are doing the background job or like doing some asynchronous processing, because some logic it takes some time to finish and you don't want to block the request. So in that case, especially in the world of Web3, and we have to interact with different blockchains. We do some jobs, and we also continuously monitor the digital asset ownership for the members, so that any change there will be reflect to our role management for the tokenized communities. So for the job server, we now have three different types of job servers. So the first one is called like the join job server, right, which is very much like you click on let's go button from Disco or somewhere, then that kick off the initial onboarding for the user, right? So the user either use an existing wallet or connect to a new wallet. And upon that time, we want to make sure the member, if they qualify for the token getting rules, then they should receive the corresponding privilege to join different protection channels. So that's where, when you click on Let's Go, you interact with our API server. That API server kind of send a job to this particular pool of job servers that handles this onboarding flow and then the initial evaluation. And the second part is like we have this each 24 hours, we try to recheck the member balance and make sure whoever get the new tokens or get new assets will be added to new roles, or somebody actually could transfer or sell their asset to somebody else, then their roles should be adjusted accordingly. So that's one of the big chunk of resource we have to invest into our infrastructure. because imagine we have to check so many different members across so many different tokenized communities, and each tokenized community might have different rules. Then we end up have to talk to different blockchains, calling different kind of API. So this creates a very interesting challenge because we are representing so many users, right? And when it comes to integration, talking to third party, oftentimes the API don't anticipate this pattern. They assume just one single user or one single developer organization try to working with the API endpoint, and the limiting becomes such a big challenge. And we sort of have to do a lot of in-house, um, like development to make sure when we make API calls, we need to constrain ourselves first without overwhelming the API provider. So that becomes a continuous challenge of talking to critical resources such as the Discord API, OpenSea API, Alchemy API. And if you look at the traffic we bring to these different API providers, sometimes just like a spammy. It's like a DDoS attack. And if you look at the dashboard we have on Alchemy, you see like millions of API calls happening from our community. So this is a very interesting challenge, and we invest a lot into our infrastructure, and hopefully in the future the communities can help us grow there as well. It's a issue of sustainability because we really want to make sure we serve our communities well, and this infrastructure cost is kind of give us a lot of headache. Not to talk about how much development efforts you put into the system to scale the system. And we try to always find ways to optimize how we, serve our communities. For example, we recently introduced event-driven approach. So the idea is for the typical background check, you pull the backend and try to understand if there's any ownership change, right? What if we can actually set up some webhooks that listen on these different kind of blockchain events, and only the relevant blockchain events will trigger a reevaluation. Say, if one particular small contract and there's a transfer event happening on that small contract, so we figure, oh, that transfer touched the two parties, right? One is the sender, the other one is the recipient. And if either the sender or the recipient happens to be a connected wallet in the Collab.Land system, then we figure, oh, we might have to do reevaluation for one of the parties or both for both parties. So that kind of inverts the control, like instead of spending a lot of efforts to pull the backend systems, then we kind of transform this into a event-driven approach, which will be much more cost-effective as well as much more efficient. Because the moment you transfer the token, you might be triggered with reevaluation, right? But the challenge again here is for some digital assets, we can use your Twitter profile to provide token gating. We can use verifiable credentials. We can use other form of digital assets. So how do we meaningfully listen on these kind of events? It's not always feasible. So we still have to work in this hybrid mode, right, to solve these kind of problems. What's interesting is, like, as we grow our user base and spin off a lot of services, we are testing the boundary of the cloud providers. So we have interesting challenge, like say, hey, we use AWS SNS and SQS as a messaging system so that we can meaningfully communicate across the different servers. Then depending on the region you are in, for example, some of the service we start from the US West One region, and that region has a much smaller capacity than the US East regions. So we had to make some, adjustment, like say, hey, move the queue, move the topic from one region to the other one, so we get a much higher rate limiter. And even we do that, depending on the amount of traffic, we are testing the boundary of the AWS services. We're getting, WebSocket, we're getting socket connection issues. We're getting rate limiting issues. It's a crazy number. Like for some of the AWS services, the number it's like 60,000 requests per second. We are even testing that kind of limit. So we have to be really creative and try to figure out how we best utilize the cloud infrastructure. So luckily, like, Russ was able to do a lot of, adjustment and build up the visibility and observability of our system, so we can meaningfully understand what's going on and make improvement over time to solve these challenges. And we pretty much use all the different interaction patterns. So we use Redis for coordination. We use Redis for state management. We use Redis to schedule jobs at different intervals. We use the messaging system such as SNS, SQS, so that we can support the asynchronous communications across the board. We use OpenSearch, which is a very powerful, time series database. And we trap different kind of events into OpenSearch so we can understand what's going on. We built metrics endpoint. We built health monitoring endpoint. We also, aggregate the logs from the different servers into a centralized place so that we can get a good idea for troubleshooting, for insight. So when it comes to the service behind a load balancer, right? Now all of a sudden it's very different from you have the ability to log into one system and see what's going on, because now behind a domain, say API.collab.net, collab.net, right? There might be 10 different server instances behind that. So how do we meaningfully manage these 10 different instances and also find ways to collect the information for troubleshooting? Those are becoming an interesting challenge. And also, if you use some cloud service, and sometimes you are being constrained by the, evolution of that cloud service. So Ross mentioned briefly at the beginning, like we use BeanStalk, right? But their platform are evolving at much slower pace than the open source project. For example, we are getting newer versions of Node.js, right? And we are getting newer version of TypeScript. We want to use this latest and the greatest technology, but the platform is sometimes say, oh, I only support Node 16, or even a couple months ago it's still Node 14, but no, it's already at version 20. Right? So how do we meaningfully accommodate this infrastructure and the platform requirements? So we have to work around that issue. Say, hey, once we deploy to BeanStalk, we have to upgrade the Node version by ourselves so that we can get the latest and the greatest version. But that's kind of the trigger to move into a containerized system, because as a container, it becomes a repeatable infrastructure, right? And repeatable meaning every single time you deploy that service, you'll get the same stack, you get the same software, the same versions, right? And also, like across the board, no matter how we divide the responsibility for API server, for job server, for like a cron server, for Discord server, it's the same code base. So containerization makes total sense because you build the same image and you just launch the image with different configuration. So that really save a lot of efficiency in our CI/CD platform, right? So with BeanStalk, it's very much you just clone the GitHub repo and you install the npm dependency, you launch the server, you upgrade this, operating system services or the dependencies. So those are very interesting challenges. So we pretty much test all the different boundary of everything. So it's kind of fun, but it's kind of stressful as well. But luckily, we have a pretty good team here. We care about the user experience. We care about how we further scale ourselves to provide that kind of reliable and repeatable service to our communities. So this is a very interesting journey, a lot of very interesting challenges. We'll continue to work on this stuff. And if you see any issues, raise your hand, let us know. So we'll dive into that and solve the root cause of any single problem. So that's our journey here. Sorry, I kind of, dump a lot of information here. Hopefully it's not really overwhelming, but it is.
I enjoyed listening to it. It's I wanted to share these graphs that we put together on the recent scaling issues. So this is looking at how many messages per second we're publishing. And we were hitting at some points like 95,000 a second. And you can see here, so 60 is officially where Amazon should rate limit us, but they don't enforce it very strictly. So we can burst quite a bit, nearly 50% over. And then you see the requests kind of fall back down to 30, where they seem to then enforce the number of requests over a certain amount of time. So this was really kind of tricky to get to the bottom of. And I think this became, if I remember correctly, apparent after the multi-wallet stuff launched. It seemed to radically increase our number of requests. And then we were getting this kind of pattern where we started spilling messages because there were too many coming in, which meant background checks had to be requeued. And so they were kind of less efficient. We made a change to how we publish these to be a little bit more intelligent and to bypass a lot of these queues and just put them directly in the workers' job pool. And this means that we're no longer anywhere near those limits we were seeing before. Like if we look at the metrics skew slightly when you go off 30 days because it's aggregating over a different bucket size. But there's no way to change that. It seems to do them in a like a 1 hour bucket instead of a 1 minute bucket. So you got to kind of take these with a pinch of salt right here, but you can kind of clearly see it built up and then it fell off a cliff, and there's not much been happening since we deployed that change. I would guess exactly at the 28th at 6 p.m. judging by this graph.
And Russ said a very good point there, because sometimes we try to improve our user experience and minimize the onboarding effort, right? So this multi-wallet support is a very nice feature for our community members because now whatever wallet you connect with Collab.Land, that could be easily, and by default we use for all the communities. But really, seriously speaking, that add a lot of pressure to our backend. Imagine by average, if a member had at least 2 wallets, then all of a sudden, we have to double the capacity for backend, because instead of checking 1 single wallet per community, now we check at least 2 wallets per community. So that basically just at least 2x of the traffic. So these are the interesting. Yeah.
Sorry, as you say, the user's probably in multiple communities, right? So it's got another dimension of scale there. Sorry to interrupt.
Yeah, go ahead. Yeah, just try to inject some, colors here so people can resonate and connect the dots.
And I guess this is pretty much the operational dashboard we've got, which we typically look at this on 24 hours. So we kind of see here when the batch is running, things start to, here we go. So this one shows quite nicely the changes we made to the rate limiting. So previously, we were kind of greedily eating all of these messages to try and process them faster. But then we hit some other bottlenecks downstream. So we implemented some other changes where now it will only process so many messages in parallel at once. So what we see is a delay in this processing. These are background checks that are being delayed. So it's not as bad as, say, a new joiner coming in. They're still pretty quick. But you can still see over 24 hours, right? There's a very clear busy period and a very clear kind of quiet period. So if you look at the next graph down, this is the event-based approach that Raymond was mentioning before. So this is where Alchemy will notify us that, hey, this event happened on mainnet, NFT, whatever, has moved from user A to user B. And then these kind of come to us in kind of little tranches, and then they'll be processed to say, is this in scope? Is this relevant? I'm not 100% sure on the exact logic, but my point is you can see it's a much more even distribution of requests. So things are happening, the requests are coming into our system as the changes are happening, or very briefly after the changes are happening on chain. And this means that say me as a user, if I go and buy an NFT on OpenSea, and that NFT is granting me a role to one of the communities, I would see that happen in near real time without needing to maybe reach out to support or ask an admin to check things, or kind of raise all these queries. So that's really nice in improving the user experience, because looking at this graph, there will possibly be a little bit of lag time from when Alchemy pick up the change and send it to us, but we're processing 100% of requests in the last 24 hours within 15 minutes that have come in. So I think that's kind of what we view as our standard, and we try to do everything we can to get this number down to 0. But the updates kind of come in tranches, so sometimes there's a very large number of events happening. It's not always easy to process those in, say, close to real time, but we try to keep it as tight as possible. And then saw some other graphs that was measuring how many messages are flowing through the system, which is the one I kind of showed earlier, where we were breaching the throughputs on the Amazon side. But yeah, that was kind of it. I just wanted to show through some of the observability pieces that you brought up.
Cool. Just do a quick time check. We have about 20 minutes left for the stage. I would like to open the floor and see if there's any questions, because really the idea to have the public secure dev office hours is to create a forum so we can have meaningful conversations. So if you have any questions here or afterward, or maybe for the next city office hour, let us know. And also, if you have any interest in specific topics you would like to see from us, let us know as well. So I really want to encourage that kind of interaction and make sure like what we deliver here is meaningful to our audience. Yeah, one of the spirit of Web3 is we kind of build in the open and learn from each other, right? So we happen to be on this interesting journey, and we have a lot of good signals from both the technology and the infrastructure and the business side of things. So we would love to share this with the broad community and inspire other people to do meaningful things as well. And hopefully this becomes valuable, and we would like to hear feedback and follow us, giving ideas, reporting issues. Also, really encourage you guys to check out our marketplace, because what we have been talking here is a kind of in-house infrastructure, right? But with the introduction of the marketplace, we actually open the door to any other developers that want to contribute value to our ecosystem. And the way it works is like, not only you can contribute to our code base directly and making that part of the code system, but now with the introduction of the Collab.Land actions, you can very much create your own microservices and deploy to your own infrastructure. And then if you conform to the API requirement and then you register that kind of endpoint with us, then meaningfully you could build a mini app which can be listed to our marketplace. So the latest baby in town is the Spark AI. So that's a knowledge base, Q&A feature that allows you to ask questions against the AI engine, and you can use the general knowledge or you can use the community specific knowledge. But really, they built this Spark AI as a Collab.Land action, and they deploy this backend system under their control, and it just stitch with the Collab.Land Bob to provide that user interactions. So those are the very interesting areas. And if you check out some of the templates we built for the Collab.Land actions or the example actions we built, you will be surprised how easy it is to create a mini app using Collab.Land actions. And we have templates for different programming languages, for different frameworks, and also showcase different business utilities. So those are some extensibility we really want to bring to the system to allow our system to be built in public, to be built together with all the communities. Chibi, do we see any questions there? Or if not, then we could go to the fun part to distribute the prop.
Hi everyone, I'm not sure if you can hear me now. I was trying to speak earlier, but I think that I was having some audio issues. But let me know. Awesome, thank you. I was wondering. Yeah, I don't see. Oh well, I see a question from James. Can you talk a little about multi-cloud initiative? Would that be for this one?
Yeah, that's a great question because we start with AWS, right? And we build some of the critical infrastructure on AWS. So when you break down the system, there's certain dependency on AWS. For example, we use DynamoDB on AWS. We use SNS SQS for messaging, but some of the service are potentially portable. For example, we have the Redis backend, we have the OpenShift backend. So those you can find replacements somewhere else, like Google Cloud or Microsoft Azure. So we are looking at the possibility to make our system cloud agnostic, so that or cloud native, so that we can have the choice. Like say, hey, some part of the service could be running with GCP, some part of the service could be running with Azure, but still meaningfully we have this composition or orchestration across the different cloud providers. So we are kind of in the process of making that kind of move to have that kind of flexibility. And one interesting idea is for some of the large communities, there even a good opportunity to have their own version of the Collab.Land. Just kind of tease a little bit because with our improvement in infrastructure as a code and have a meaningful way to customize the system. So imagine if you are a large community and you want to utilize the Collab.Land stack for your own purpose without sharing the competition with any other communities, right? So I think technically there's a path for you to do so. So you can pretty much use our stack and kind of have your own version of Collab.Land running with your communities. So that could be a potential enterprise plane. But technically, we're kind of making that possible over time and allowing these choices of different cloud providers or even support multi-cloud. That's very flexibility, for the infrastructure for that kind of deployment as well. Any other questions?
Awesome. I don't see any other as of the moment, but maybe while people get to them, we can distribute the POAP in the meantime. What do you think?
That sounds good.
Awesome. So for everyone in the audience, thank you so much for joining. As always, we're super happy to have you. And if you would like to claim today's POAP, we will do so by using the POAP mini app. So all you have to do is to use the / command called POAP claim. So you can write in the chat / POAP claim. And today's claim phrase is programming. And the secret phrase is programming. Only that single word, all lowercase. There's no spaces anywhere. That would be PROGRAMMING. Programming. Once that you write the secret phrase, you can hit enter and you will receive a code to claim your POAP. Please let us know if it worked. Awesome. I see that James was able to claim. Thank you, James. Awesome. I also claimed mine. Again, the secret word is programming. Awesome. I see successful claims in the chat. Thanks everyone for letting us know. And again, if you have any questions, please feel free to drop them in the chat, or you can also raise your hand and we will bring you up in the stage, whatever you prefer. Also, if you don't have any questions right now, you can also drop them in the chats later and we can answer to them in the next CTO office hours. And you can also suggest topics for the next CTO office hours as well. I see one question about the POAP. Where can I claim? So, Adik, all you have to do is to write in the chat /POAP claim. I'll take a screenshot real quick. And send it to you. /POAP claim. And the claim phrase is programming. Oh, thank you so much. These are designed by Anjali, and I think they're beautiful. I really like these pop-ups. Glad that you guys like them. Thanks, everyone. So nice to read your comments. Also, if you have any feedback about these CTO office hour sessions, you can drop them in the chat as well. We love to read your comments and feedback about what we do. So that's always very important to us. So please feel free to let us know. All right, I see some people writing in the chat, so let's see if they have any questions. And otherwise, I think that we're ready to wrap things up. Let's just take a minute to see if anyone has any questions. Oh no. Parmagata, are you getting any errors? Can you show us what it's telling you? Maybe we can troubleshoot real quick. Oh, okay, so let's repeat the secret word one last time. It looks like this error is related to that. So it's just one word to claim the POAP, and the word is programming. That's PROGRAMMING. Programming. Is that the word that you heard before? And if not, please try again and let us know. Awesome. All right, I don't see any other questions, so I think that we're good to wrap things up. But again, if anyone has any questions, please drop them in the chat. We'll make sure to get back to them in the next CTO office hours, maybe, or we'll answer to them in the chats.
All right. Thank you so much for attending, and thank you so much, Russ, for presenting.
Yay, thanks, Raymond and Scooby. This was very interesting. It was a great session, and thanks everyone in the audience for attending. We're always really, really happy to have you here.
Cool. See you
All
next
right, we'll
time.
see you guys. Yeah, see you next time. Thank you. Bye-bye.